In one of the earlier videos, we discussed why legacy security and networking is inadequate for work from anywhere and digital transformation. So work from anywhere and digital transformation. So legacy network security and networking fails to address the work from anywhere and digital transformation use cases. We also learned how cyber mesh can consolidate these point solutions, all the point solutions as shown on the left, and add new capabilities like XDR and 5G services and deliver these capabilities as a single cloud service. So all the legacy point products, consolidate them, add new capabilities like 5G services and XDR, and deliver all these as a single cloud service from the cyber mesh. Cyber mesh is built on a multi-cloud native Kubernetes using pods, containers, and microservices. There are two main parts to cyber mesh. Cyber control. Cyber control serves as the brains of the mesh, centralizing policy, orchestration, and distributing policy enforcement. Cyber nodes are inspection and enforcement engines distributed globally at edge locations or even on-prem. Edge locations on-prem, and they need to be closer to the user. The on-prem use cases are really when you are doing 5G edge computing, ultra low latency use cases, and so on. So the cyber nodes are cybersecurity and digital experience engines with intelligence built in. So the intelligence built in through the AI and analytics. Cyber nodes are aware of the identity of a person, thing, or an asset connecting through it. So the security and networking is aware of the identity and context. Right? So XDR is the centralized service. XDR, extended detection and response, is the cross-layer detection and response. Since XDR collects and automatically correlates data across multiple security layers like edge, endpoint, server, cloud workloads, and network, it needs to be centralized. So XDR makes sure that threats are detected faster, and security analysts improve investigation and response times. So our goal with the cyber mesh is to securely and intelligently connect people, connect things, and connect processes in new and interesting ways using a single cloud delivered service. So really addressing the needs of the modern digital enterprises that need an integrated secure access and cyber experience platform to compete in a cloud first world. We just learned that cyber mesh delivers SASE, secure access services edge, XDR, extended detection and response, and 5G services on a single platform. SASE services are further delivered in two parts. We'll see the part one will be secure private access, and part two will be the secure internet access. So there will be total 4 services, 2 part of SASE and XDR and the 5G, IoT, and edge services. Before we get into these services, let's look at the 3 building blocks of the cyber mesh. Cyber mesh 3 building blocks are the cyber control, cyber node, and zero trust path. Cyber control is centralized policy orchestration. You have unified console and dashboard, so single pane of glass for all these services, centralized policy orchestration. Policy enforcement is distributed in the cyber nodes, but policy orchestration is centralized in the cyber control. So cyber control is serves as the brains of the cyber mesh. And then since cyber mesh also delivers 5G services, there is a 5G control part that is centralized. And then XDR and AI and analytics are also in the cyber control. You will see why we need these things centralized, because you are going to gather data for analytics from the endpoints, from the network, from the cloud, edge, from all those sources. So you do a better job when you have all that data at a central place. So this is cyber control. Now let's look at the cyber node. So what is in a cyber node? A cyber node has a zero trust security built into that, network security built into that. So that means it has firewall as a service, and the cloud firewall. It has a secure web gateway for all the web controls, URL filtering, web categories filtering, and all the web protections. It also has a cloud access security broker, or CASB, for SaaS applications control. Then it also has zero trust network access, because it's a zero trust security built into that. Then Cybernode, because Cybernodes are policy enforcement points, cyber nodes also control the digital experience, like the user and the asset identity and context aware digital experience management is done in the cyber nodes. Cloud SD-WAN, software-defined wide area networking capabilities are also delivered from the cyber nodes. So the things like application routing, traffic shaping, traffic steering, SaaS acceleration, all those capabilities are delivered from the cyber nodes. And since Cybernode and whole mesh is built based on the 5G standards, Cybernodes also deliver 5G services. So the cyber control is centralized, while the cyber nodes are distributed globally, because you need to have cyber nodes closer to the users. The reason, wherever you are, like a remote user, you are going to connect to the closest cyber node. So then your security processing, cloud-based security processing, is going to be done in the cyber nodes. So that is going to determine your user experience. If your cyber node is too far away, just due to the time it takes for your packets to get there, digital experience or your experience may be compromised. So you want to have as many cyber nodes globally distributed closer to the users as possible. We saw the cyber mesh is deployed in the public cloud infrastructure and into the bare metal colo infrastructure to create as many points of presence or cyber nodes as possible. So when you connect as a remote user or from the office or a mobile user, or even as a IoT and operational technology critical infrastructure to the cyber mesh, you connect over the trust path. So these lock signs are a trust path. So what is a trust path? The number one, it is a secure zero trust path. That means it is established using the zero trust exchange. So the identity confirmation and the confirmation that a legitimate device or user is trying to set up trust path is built into that. On top of that, you have the silicon root of trust, or you can say hardware root of trust. For example, we have seen a lot of the cyber attacks where it was just the hackers, bad guys were able to get access to the passwords and were able to use those stolen credentials to compromise the systems. With hardware root of trust, your root of trust or credentials are in a way pinned to the device, like it's stored in a chip on the device. So if bad guys need to have access to your device in order to get access to that, they cannot just be anywhere in the world. And for example, which is the case for passwords, can use your password to access to your applications and services. So hardware root of trust can be built into, for example, if you have a Windows laptop, there's a trusted platform module chip. So you store the credentials there. If you have a Mac laptop, there is a secure enclave. Apple has secure enclave. And then if you are on a mobile devices, there is a SAME or eSAME hardware root of trust can be there. If you're on a Linux device, there is again a TPM. Or on a server, there is a TPM, and there are various other ways to create this hardware root of trust. We know Apple uses hardware security for some of their services like biometric data for Face or Touch ID, as well as Apple Pay data, because you want to make those services secure. But what about all the other applications with the trust path? Cyber Mesh extends hardware security to all the application and services, because once this trust path is set up using hardware root of trust, you are a remote user or in the office, now all your applications and services are going through the trust path. That means they are protected with the hardware security, hardware root of trust. Then TrustPath has the network layer encryption, decryption. We saw even when you have HTTPS, you are open to a lot of network layer attacks. These include like the sniffing and eavesdropping, because if there is no encryption, even though have HTTPS is the application transport layer security, but someone can still do the sniffing at the network layer. Like they may see which websites are you going there. So there's almost no privacy with that. And then your DNS is also going domain name server queries are going over the open internet, and from there you can see which content or websites you are trying to access. Then you are also exposed to man-in-the-middle attacks, because anyone can enter at the network layer. You don't have network layer protection with HTTPS. You have distributed denial of service attacks because you are exposed at the network layer. For example, TCP SYN floods, because even though you have HTTPS, but you will accept the TCP traffic, and basically with TCP SYN floods, the offender sends TCP connection request faster than the targeted machine can process them, causing network saturation. And you are also open to network intrusion, because there is no protection on the network. And but once you have the IPsec is really the IP layer, like it's the network layer protection. So you protect against all these attacks with that. Then the third part is really a generic route encapsulation for quality of service control. So these trust paths are compliant with the 5G standard, global standard, and there's a whole very sophisticated quality of service framework, like the digital experience control framework in the 5G standards that CyberMesh leverages. Like since the trust path goes all the way to the devices, so basically the cyber node and cyber control can tell the device to prioritize, for example, Zoom traffic or Teams traffic, more interactive traffic over, for example, OneDrive backups. Right? So the quality of service extends all the way to the devices with this quality of service control information that goes inside the GRE path. Then trust paths can carry any protocol, in particularly for IoT and operational technology, critical infrastructure. because internet was built for IT applications, TCP/IP protocols. A lot of IoT and OT devices use different protocols, and in some cases unstructured data, but everything can be securely carried inside the trust path, even for IoT and OT. Earlier we said before we can have a Internet of Things, we need to build Internet for Things. Like so, this cyber mesh is really have this ability to carry any protocol. Is building an Internet for Things with this cyber virtual Internet overlay layer that we create. And the trust paths are access agnostic, so you may be going over any transport, Wi-Fi, broadband, 4G, 5G, even though they're based on the 5G standard, but 5G is access agnostic. That means 5G can go on any underlying transport. You can deliver 5G services not over only on 5G radios, but also Wi-Fi, broadband, fiber, even satellite, like any transport. So now we have covered the three core building blocks of the cyber mesh, the cyber control, cyber node, and trust path. Let's now look at the services that cyber mesh offers. So first, let's look at the two SASE services. So there is a secure private access and secure internet access. Secure private access means that you can be a remote user in the office, mobile, you're trying to get access to the private or corporate applications running in the data center, on-prem, on a co-location facility like Equinix, or your workloads and private applications are running in the public cloud. You are using public cloud as infrastructure as a service or platform as a service. So the way the cyber mesh is going to work as a remote user. For example, I am taking example as a remote user. A remote user is going to set up a trust path to the closest cyber node, and then there will be this a piece of software. We call it cyber gateway. That will create a trust path to the closest cyber node. Similarly, from the public cloud, this trust path will be created. Then in the cyber mesh says each cyber node in the mesh is connected to all the other cyber nodes. So it's securely using the trust paths, again, the zero trust paths. So no one can, so whole cyber mesh is invisible on the public internet because it is all protected inside the trust paths. So with this one, now you can be anywhere in the office, mobile, remote. You can get access to the private application. That's why we call it secure private access. And this is a very different, like now data center is not the center or hub. You are not going through the data center when you are, for example, going into the public internet. You actually, cyber mesh creates the shortest and fastest path between wherever you are, because you connect to the closest cyber node and your applications connect to the closest cyber node. And then cyber mesh creates the shortest path between these two cyber nodes. And you only need to have a one trust path to the cyber mesh. And then you may be accessing applications in the data center, on-prem, in colo, or in the public cloud, multi-cloud, any number of public cloud, Azure, Google, AWS, IBM, Oracle, it doesn't matter. So with one capability, trust path, you have policy-based access control. Of course, you have a very fine-grained control with the policy, which applications you can access with this with cyber control. And then the second set of applications are secure internet access. Like so, a secure internet access means you going to the enterprise SaaS like Salesforce or Slack, Office 365, Google Docs, and all those different services, or even consumer and web apps. And in this way, you create secure pairing with the SaaS application. So cyber nodes, cyber mesh creates the secure pairing, and also it does the source IP location obfuscation. So when you are going to, for example, to the web applications, these applications cannot know about your location or your identity and others. So it provides the full privacy. So this way, there are two services are delivered from the cyber mesh, and since with the zero trust paths, you are protected against all the, even though these applications may be using HTTPS, it is okay because now you have the network layer protection with the trust paths. And the third service that CyberMesh delivers is XDR servers. Right? So the XDR servers is basically XDR applies AI analytics, automation, and orchestration to make the cyber threat detection and response precise, automatic, faster, and easier. So you are able to detect the malware, ransomware, phishing, man-in-the-middle attacks, DDoS, and botnet attacks. You are able to stop those attacks when you combine XDR with the secure access services edge capabilities. And then the fourth set of services is the 5G scale IoT edge computing. This allows to deploy cloud native software locally on any general purpose compute infra that will deliver cyber mesh as a server. So in this case, you bring the cyber node on-prem, because a lot of now your processing, like according to some studies, by 2024, about 70% of the data will be processed at the edge. Right? So even you will have IoT devices, you want to prevent lateral movement. So you bring the cyber node with all the cyber node capabilities, like with the firewall built in, and the zero trust network access built in, and all those capabilities, digital experience built in, and the 5G edge services that you can deliver when you deploy cyber node on-prem. But the overall service is still delivered as a service, as a subscription service. So with the cyber mesh, there are three building blocks: cyber control, cyber node, and trust paths. And you deliver four services: secure private access, secure internet access. So these combined, you can call them secure access services edge. And then you have the XDR services and the 5G secure IoT and edge services delivered on a single platform.